Hello and welcome back to Vectors with Vector.
Today we'll be covering how to find the angle between two lines, the angle between a line and a plane, and the angle between two planes.
Before watching this video, you should be familiar with the vector equation of a line, the vector equation of a plane, and the scalar or the dot product.
We will cover some of these concepts briefly before continuing. You should be familiar with the vector equation of a line. The first vector represents the position vector of any point on the line, while the second is the direction vector of the line in 3D space. It is helpful to note that the direction vector of a line can always be simplified or scaled by a constant factor, and that the vector itself lies on the line.
Keeping this fact in mind, it becomes clear that the angle between two lines is identical to the angle between the two direction vectors of the line.
In order to find the angle between the two direction vectors of the lines, you can use a dot product.
Let's start by comparing the geometric and algebraic equations for the dot product of two vectors. Using this comparison, we can find the value of theta.
Take a look at the example below. As you can see, we compared the algebraic definition of the dot product with the geometric definition of the dot product. By rearranging this equation, we can solve for theta. From this process, we can derive a general equation to find the angle between two vectors.
Now let's look at the equations of a plane. The first equation as shown is a Cartesian equation. What's interesting to note is that the coefficients of x, y, and z come together to form the components of the normal vector.
The first step to finding the angle between a line and a plane is to find the direction vector of the line and the normal vector of the plane. Then we'll follow the same steps as before to find the angle between these two vectors.
An important note to remember is that this angle gives you the angle between the normal and the line. And what we want to find is the angle between the line and the plane. So to do this, you would either need to subtract the angle from 90 or add 90 to the angle to find the obtuse angle.
The process of finding the angle between two planes is similar. Use the equation to find the angle between the two normal vectors. It's important to note, though, again, that the angle found will be the angle between the normal vectors. In order to find the angle between the two planes, you would need to subtract this acute angle from 180.
And that's it. Thank you for watching Vectors with Vector.